Welcome back. Now, for first order backward difference, we are done with first order forward difference. For first order backward difference, what you need is what? You just go through negative side of x from the 4 cardinal points and the positive side of and the negative side of y. So that's, you use the 2 for what? For first order backward. It's backward movement like that. Then you are going back. So now the equation is what? The equation for the negative x decrement, and that's your equation 2. So we use this one to get forward, to get first order backward difference along x axis, x direction. So now this is the formula, like the way we did for the first order forward difference. So that we bring out this t subscript s comma y, bring it out. That's why you are seeing it as minus t subscript s comma y here. And I told you that the remaining thing here is for the negative. I said you multiply it by minus 1. The first one by minus 1 raised power 0, which is also 1. Minus 1 raised power 1. So that's why you are seeing negative here. This minus sign. So don't let it affect you. So delta x over 1 factorial and so on like that. Like this. You don't need to waste time on this. You already done for the first order. So it's like we are repeating it. So what you need to know is that you make sure you know what you are doing. Don't just memorize or cram it. Know what you are doing. So the next step is what? Divide both sides by delta x. We are in x direction. If it is y direction, you divide by delta y. And if it is y direction, you will see all these ones, they are what? The x is now delta y. It's now the y for y direction. But we are still in x direction. That's why you are seeing x. This is the x here. And that's why you are seeing delta x here. So divide both sides by delta x. So you divide the left side by delta x, the right side also by delta x. That's why instead of delta x over 1 factorial here, like this one. So instead of it, 1 factorial is also 1. So don't waste your time on that. Divided by delta x, and delta x cancel delta x. So you divide it each one by what? Divide each one by delta x. This one also divided by delta x. Delta x cancel 1 out of the square here. And also here, delta x cancel 1 out of the cube here. It remains 2. It remains delta x square. So the remaining one is this. So we now rewrite it like this. And you know that if delta x, this delta x, we say is small increment, is small. It means delta x square and delta x cube will be very, very small. So turn everything to 0. Just assume they are 0 because they are very, very small. So the only thing remains is what? This dt subscript s comma y over the x equals to this. And this minus is there. So don't let the minus affect you. So you now multiply both sides by this minus 1 to cancel this minus out. So when you multiply both sides by minus 1, this one will now turn to plus. That's why you are saying dt subscript s comma y over dt. Here, this one, you multiply it by minus 1, both sides by minus 1. So that in order to cancel this, to eliminate this minus, that's why you're multiplying it by minus 1. So you multiply this one by minus 1 now. It will now be minus t subscript delta x minus delta x comma y plus the minus. If the minus multiply this one will now turn to plus. It will now be minus this, and this one is plus. You just rearrange it to avoid negative start the equation. So that's why you are rearranging it. That yours now bring the positive one forward like this. It will now be t subscript s comma y minus t subscript s minus delta x comma y all over delta x. That's the remaining one here. So using double subscript notation, you change your s to I and your y to j, and your delta x increment here return to 1. That it will now be x minus 1 comma y comma, it will now be I minus 1 comma j, because you are using double subscript notation now. So, and your delta x will change to h. If it is delta y, it will change to k, increasing towards y direction. But this one is x direction. Increment towards x direction is h. So using the double subscript notation now, the answer will now be what? D T subscript S comma Y like this is now I comma J over the X equals to T subscript I comma J minus T subscript I minus 1 is not X minus delta S again, comma J. Your delta S is now H. This first order backward difference in your what? X direction. Backward difference. You see it's backward difference. So when you see this one is minus I minus J. For forward difference in X direction is I plus J. I plus 1 comma J. But in backward now is I minus 1 comma J. And this one is at this side. So note that. This for the S direction. You do this for the Y direction. Just change this delta Y. Anywhere that you see the Y, the X, change it to the Y. And anywhere you see delta X, change it to delta Y. Do the same thing, follow the same step. You get this. This is what you get. So for first order backward difference in Y direction, this is the equation. So let me quickly do it. Using equation 4. You know equation 4 is for negative decrease in Y. So negative Y direction. So that's what you are saying. Follow the same step like this. Divide both sides by delta Y. It's not delta S again. It's now you are now in Y direction, delta Y. You get this. The same trend. Cancel delta Y, cancel square, remain square here, cancel here, remain 1. Rearrange, and don't forget this minus. So when you get to this stage, you now do what? Your answer, multiply this side, both sides by minus 1. This one will turn to plus. That's why you're seeing it's like this, like this. Because delta Y is small. Delta Y is small. Then what? Delta Y square. This one is like, okay, now see to be delta Y. And this one is delta Y. So the small increment. So because delta Y is very small, it means delta Y square will be very, very small. So turn everything to 0. It remains this one only this and this. So come to this side. Minus dt subscript sy over dy plus everything others. This one we turn it to 0 because it's very, very small. Equals to the left side here. So now to remove this minus, you multiply both sides by minus 1. This one will now turn to plus. Cancel. This one will turn to minus t subscript s comma y minus delta y. Y is now decreasing. Minus times this, minus times this one, minus multiply by this. You multiply both sides by minus 1. Minus 1 times this turns to this one to minus. Minus 1 multiply by this. This one will now change it to plus. We now rearrange this. Bring this one to this side and bring the negative one to the other side. So let's see it. So you can see now the minus 1 is multiplying everything. Minus 1 is multiplying everything. So now this one will now turn to positive. Using double subscript notation now, you change your x to I and your y to j, and the increment here is now 1. Meanwhile, your delta y will turn to what? To k. So this is what you are seeing here. dt subscript I comma j dy equals to t subscript I comma j minus t subscript I comma j minus 1, because y side is now decreasing. There's not, as in I will just be looking. So divided by your delta y is what? Is k. Divided by k. So this for the first order backward difference along y direction. So we now add the two together, the x and the y together, to give you first order backward equation. So you get. So for central now, let me add this so that you understand everything once. For central difference, the four equation that you first did, the first 4 equations that we did at the beginning of the other video. So it was that you don't mistake it. This central difference is closer to this second order difference that we do after this. So it means to get this, you do what? Subtract equation 2 from equation 1, and equation 2 is what? Is the negative side of now let me go back so that you understand. Negative side of x direction. Negative side of x direction. You know, equation 1 is for positive x and equation 2 is for negative x. You subtract this one from this. Just bring it one by one. This minus this at the left side equals to t subscript s comma y minus t subscript s comma y. Cancel out. So let's go back to it now. So note that this equation 1 for the positive x, it means for your central now, you are moving along the central line like this. For the x direction, you are using 2 both sides now. It's not just only positive side. For the y direction, you are using positive side and negative side. You are moving through the center line. So it means you do for the y direction the positive y minus the negative y. For the x direction, positive x, equation for the positive x minus equation for the negative x. So let's quickly go back now. Now this is it. Subtract it. You know this cancel out, cancel. You now bring, just take it one by one. The one from the equation 1 minus this one from the equation 2. You see, this is how it's doing. You know this one is d t subscript xy comma dy dx delta x over 1 factorial plus this one is for the equation 2. For the equation 2, you know it's also positive. That's why you write it like this. Plus this, the third, the one and power 2 for the equation 1, the square t subscript this like this minus the one of the equation. If you know that from the equation 2, this d is minus d. So because it's negative already, that's why it's now turning to positive here, because we are subtracting it. It's now be minus this one. That's why it's turning to positive. For this one now, from the equation 1 minus the square from the equation 2 plus the cube from the equation 1 plus minus, you know, from the third one was in equation 2. Third one is also minus 1. Minus is also negative because we are multiplying it by minus 1 to power 3 there. It's also negative. That's why, because we are now subtracting it from the equation 1. This one is for equation 1 and this one is for equation 2. Minus in front of that equation 2 now turn it to positive here. So now equate it. This cancel this. This one also cancel this. It remains this equals to this plus this is 2. It just like the coefficient of this one is 1. Coefficient of this one is also 1. The coefficient of this one is also 1 and 1. 1 plus 1, 2. 1 plus 1 here, 2. That's why you are seeing 2d t subscript s comma y dx delta s yes plus the plus 2 also for the cube, also for the d the cube t subscript s comma y. So that's why you are seeing 2 there. You just add this together and add this one together. So when you add this, the next thing was you divide both sides by 2 delta x, because you are moving forward, you are going along the central axis, the positive side and negative side. The positive when you are doing for the first order by backward difference, you know, when you are using negative x axis, you do what? You divide both sides by delta x only. When you are using negative y axis, you divide both sides by delta x only. But now you are using both positive x axis and negative x axis. So that's why you are using dividing by 2 delta x. Now you are going through this double direction. That's why you double your this one also. You double this also. You divide through everything. 2 delta x divide through by this. When you are dividing it, you know this one have how many delta x? Only 1 at the numerator. Divided by 2 delta x down. So for this one also, this one is also square. The 2 here, when you divide this one, delta x will cancel delta x, and the 2 will cancel these 2. 2 delta x that will be at the numerator, at the denominator that you are using to dividing it. So you cancel it, it will remain this. That's why you are not seeing this 2 here again. You know the 2 is here before. Because you divide it by 2 delta x, that's why you are not seeing it here again. So plus the second one also that you are seeing 2, these 2, I already divide this, cancel out with these 2 delta x that you are using to divide both sides. So that's why you are not seeing the 2 here again. So and delta s remains what? Delta s square. You know delta s keep here. Because it's 2 delta s cancel, it remains square. So if delta s is small, then delta s square is what? Very small, smaller. It's smaller than delta s. So you just turn everything here to 0. It remains this only first derivative. So that's why you are seeing it like this. And the 2 delta s that you use to define this one is there. It remains there. So using double subscript notation now, you just rearrange it, put this one equal to this. That's why you have it. And you know that your delta x is what? Is h. When you are using double subscript notation, your x return to I and your j return to your y return to j and your increment return to 1. That's why you are seeing this here. Check it very well. So 2h. And this is the first order central difference along S. Likewise, y-axis now using equation 3 and equation 4. You now see equation 3 minus equation 4. You know we are saying equation 1 minus equation 2 for S and S-axis, S direction. For Y direction, you use equation 3 minus equation 4. So that is what you get. You know, for everything anywhere you see delta S here, just substitute with delta Y. That's the only difference. Delta Y, the Y, or this delta Y instead for the Y direction. So this is what you have, and you know your delta Y is not H, is K. After when using this double subscript notation, and your X return to I, Y return to J. This is the first order central difference. So note that. So I don't want, just quickly run through this one so that you finish everything once. For second order difference, you know we are subtracting. For first order difference, we are subtracting, we are saying the equation for the positive s direction minus the equation for the negative s for central difference to know everything at the center, using the center line like that. For the y direction, we said positive y minus negative y. You now add both, what you get from this s, positive s minus negative s, that's for s direction, minus what you get from positive y minus negative y, that's your y direction. You now add everything together equal to 0. It give you total equation for the central difference. So now second order difference is what you would add equation 1 and equation 2. You are not subtracting it again. It's not, you are adding it now for second order. For central difference, you are subtracting it. For second order now, you add equation 1 and 2. You'll be adding it like the way you did in the central difference. You just be adding it. So this is what you get. So you see, adding, very small along x-axis. This is what you get. And you divide by 2 delta x, that like the way you did here. 2 delta x. So for the along y direction, you use what? You'll be no. You are instead of dividing by 2 delta x, you'll be dividing it by delta x square. Delta x square. That's why you'll be dividing it with delta x square here, not 2 delta x. So for the second order difference, so you can check it very well. So this along x-axis and this one is for along y-axis. You now add along x-axis plus along y-axis equal to 0. This is what you have. And this is your what? Second order difference equation. So I think that's all for the differential, for the first order difference and forward difference and first order backward difference and central difference and also second order difference. So I wish you best of luck. So try to understand. If you don't understand anything, let me know. That's all. Good day. Bye.